Good afternoon to all. In the last class we discussed the structure of embryo, how the dicot, the development of embryo takes place. In dicot or in monocot, the development of embryo is more or less similar. And we have seen that there are 4 stages for the development of embryo. Before that, development of endosperm takes place in angiosperm. Endosperm is the storage food for the growing embryo. Endosperm development takes place by 2 methods in angiosperms. In the first method it is called cellular type of endosperm development, and the second type is called nuclear type of endosperm development. Endosperm is the tissue which stores food for the growing embryo, and it is diploid in ploidy. Then see the development of, after the development of endosperm, development of embryo takes place. Zygote develops into embryo. That process is called embryogenesis, and during that the zygote divides into a structure called proembryo. That proembryo develops from the tips end of the proembryo, develops into a globular embryo, embryo proper or globular embryo. That globular embryo develops into a heart-shaped embryo, and which develop into mature embryo. So there are 4 stages: proembryo, globular embryo, heart-shaped embryo, and mature embryo. 4 stages are there, and in the last class I explained. Today we can discuss the structure of seed, dicot seed and monocot seed. Structure of seed. And already I explained that the zygote, the ovary, develops into fruit after fertilization. The ovary, this part of the flower called as ovary, gynoecium, this ovary develops into fruit, and inside there is the ovule. This ovule develops into seed. Ovule develops into seed, and ovary develops into fruit after fertilization. So the say this is the seed, ovule develops into seed and ovary develops into fruit. Normal cases, fruits are developing without fertilization, that we can discuss later on. Anyhow, today we can discuss the structure of seed, dicot seed and monocot seed. Structurally somewhat different. A typical seed in angiosperm consists of 3 parts. See, I am just representing the dicot seed firstly. Dicot seed or bean seed or castor seed or tamarind seed. A typical seed consists of 3 parts. See, a covering of the seed called as seed coat. See, there are 3 portions are there. First of all, a seed coat. Seed coat. Second one, storage food. 3 portions are there. Yes, covering of the seed called seed coat. Then there is a storage food. Then an important part called as embryo. So a typical seed consists of 3 portions. A covering of the seed called seed coat, a storage food inside, and inside there is an embryo. So typical seed consists of 3 portions. And of the 3 portions, the outer covering is called seed coat. Covering of the seed is called seed coat. It will protect the embryo inside. And the seed coat may be having different colors are there, different designs are there, different appearances are there. Anyhow, the covering of the seed is called a seed coat. It consists of 2 layers. The outer layer is called testa. The outer layer is called testa, and there is another inner layer. This inner layer of the seed coat is called tegmen. Inner layer is called tegmen. Tegmen. So, seed coat consists of 2 layers. Outer hard colored part called testa, layer called testa, and inner layer is somewhat thin in appearance. It is difficult to separate. The inner layer is thin, and that inner layer is called tegmen. So seed coat consists of 2 layers. Seed coat consists of two layers, outer testa and inner tegmen. Testa colored and hard, and tegmen is soft and thin. So layer is called seed coat. Covering of the seed is called seed coat, and protect the inner portions. And inside the seed coat, there is a second part called storage food. This is the, see, on the testa, before that, on the testa, a small marking is there. A small marking, a concave part, a small marking. That marking is called hilum. H-I-L-U-M. You may remember the hilum of ovule. And near the hilum, there is a very small opening called as micropyle, through which exchange of gases takes place. So, the testa, you may remember the covering of the ovule called as outer integument and inner integument. That outer integument develops into tegmen and inner integument develops into testa. And on the ovule, see, there is a point called hilum. And there is a small opening called as micropyle in the ovule also. That small opening, micropyle, remains as such, and can see the micropyle on the seed also. There is a very small opening. It is very difficult to identify. Through that, exchange of gases takes place to the seed. So the seed coat you have to represent these bunch of portions: testa, tegmen, hilum and micropyle. And inside that, there is the storage food. It contains large amount of storage food. So it contains storage food. Storage food may be two cases. It may be either in endosperm. It may be either in endosperm or in cotyledon. Two cases are there. In many plants, the food is stored in the endosperm, in monocots, most of the monocots, and in dicots, mostly the food is stored in the cotyledon. You are seeing there are two types of seed, without endosperm and with endosperm. Anyhow, the storage food is present, that may be either in the endosperm, in monocot, or in the cotyledon, in dicot. So second part called storage food. Then comes to the third part, is called embryo, and that is a very important part that represents the next generation. The embryo which develop into a small plant and a small plant. So embryo can be seen here inside. See, you can say small embryo. This is the embryo. Very important part called as embryo. That the embryo represent the next generation. So anyhow, a typical seed consists of three portions. A covering called seed coat, which have two layers, and storage food, maybe either in endosperm or in cotyledon, and third part called, important part called embryo, which develops into, which is developed from the zygote, which later develops into the next future plant. So this is the storage food for the growing embryo, because embryo cannot, during the early stages of germination, embryo cannot prepare food material. So till the development of first pair of leaves, the food is not to be used for the, this is the storage food for the growing embryo. So anyhow, three portions are there: seed coat, storage food and embryo. So clear that. Then see the structure of embryo, dicot embryo and monocot embryo. And yesterday we have seen the structure of dicot embryo. I will revise once again. Dicot embryo, that may be dicot seed, can open any groundnut or castor or like that, beans or like that. Dicot embryo, just I will revise once again. Dicot embryo consists of an embryonal axis like this. Base of the embryonal axis is called radicle, and tip of the embryonal axis is called plumule, and which is covered by first pair of two leaves, and the plumule develops into shoot system, and radicle develops into root system that we have seen in the first year. As far as a typical angiosperm plant is considered, there are two portions, part of the plant going below the soil level and part of the plant going above the soil level. So, have an embryo, this is called embryonal axis. Embryonal axis consists of a radicle and the tip is called a plumule. There are two cotyledons laterally attached. They represent the cotyledons like that, simply represent like that. These are called cotyledons. I revise once again, which is explained in the next class. Two cotyledons are there. You can see that, call it as dicot, having two cotyledons called as dicot. I can see the seeds like groundnut or maybe cashew nut or beans or tamarind. You can see two pieces inside the seed. That is called cotyledon. Two pieces are there, two cotyledons are there. Food is stored in the cotyledon. In dicot, food is stored in the cotyledon. The part of embryonal axis below the attachment of cotyledon is called as hypocotyl. You may remember the word hypodermis. Hypo means below. So, hypogynous flower. See, the part of the embryonal axis, this part is called as hypocotyl. And the part of embryonal axis above the attachment of cotyledon is called as epicotyl. This part is called epicotyl. Part of the embryonal axis above the attachment of cotyledon is called epicotyl. Part of the embryonal axis below the attachment of cotyledon is called as hypocotyl. So this is the structure of dicot embryo. Diagram is very important. Questions are usually asking differentiate between hypocotyl and epicotyl. So embryonal axis, tip is called plumule, which develop into later shoot system, and base is called radicle, which later develops in the root system. Two cotyledons are there in dicot, and the part of embryonal axis above the attachment is called epicotyl, below is called hypocotyl. This is the structure of dicot seed. Then see the diagram of structure of monocot seed, that is very important. See the diagram of monocot seed. Monocot seed, usually we represent maize seed. Maize or rice we can represent. Monocot seed, first year we have seen the diagram very clearly. I will revise once again. Monocot seed. Suppose the rice or any example you can say. I will give example of the rice, monocot seed. And monocot seed consists of endosperm. 90% of the seed is endosperm. So endosperm is covered by a protein layer called as, you know that, there's a name for that. This layer is called alluron layer. Endosperm is covered by a protein layer called alluron layer, and this is the endosperm. This is the endosperm. The 90% of the seed is occupied by the endosperm, and this is the major part of the seed is occupied by endosperm, and the endosperm is covered by a layer called alluron layer, protein layer called alluron layer. And at one corner we can see a small embryo can be seen here. Embryo is occupied at the one corner of the seed, and there is an embryonal axis. Similar to that, there is an embryonal axis. That I explained the first year. This is the embryonal axis. The embryonal axis, and the tip of the embryonal axis is called plumule. There is no difference. And base of the embryonal axis is called a radicle. And there is a single cotyledon. You may remember this is a monocot. So there is only one cotyledon. The single cotyledon of monocot is called a scutellum. In the last class, the first year I explained that single cotyledon of monocot is called scutellum. And the radicle plumule is covered by a cap-like covering. And this cap-like covering is called remember, coleoptile. And the radicle is covered by another covering called coleorhiza. See, radicle is covered by coleorhiza and plumule is covered by coleoptile. So remember, this is an important diagram for second year also. And you have to draw the diagram. The diagram may be given. You have to label that. So you have to label. First of all, this is the alluron layer. One important labeling. Second is the endosperm. Third is the coleoptile. Fourth is the scutellum. Fifth one is the coleorhiza. And so these have label. These bunch of things, important one, alluron layer, coleoptile, scutellum and coleorhiza. These are all important terms. Questions can be asked. Labeling is important. So these are the, so I will explain once again. The monocot seed consists, 90% of the monocot seed is endosperm, which is stored for material. So endosperm present, so-called endospermous seed or albuminous seed, monocot seed. Endospermous seed, albuminous seed, different terms can be used for examination purpose. So 90% is occupied by the endosperm. Then the small part is occupied by the embryo. There is an embryonal axis as in dicot. A covering is called, tip is called radicle, plumule, and base is called radicle. Radicle is covered by coleorhiza. Plumule is covered by coleoptile. Single cotyledon, because it is a monocot, then single cotyledon of monocot is called a scutellum. There is an alluron layer covering of propyla, and those this is an important diagram. So both the diagrams are important for you. Dicot and monocot seeds are important for you. So I think it's clear for you because it is a repetition from the first year. See the structure of seed. This is the final product of fertilization. Then what is the importance of seed? Seeds are very important. So a small topic. What is the importance of seed? Seeds are very important. So what is the importance of seed and how it is related to human being? First of all, seeds are very important. That is the final stage of fertilization or reproduction. The final aim of fertilization is the production of seed. And what is the importance of seed to human beings? And seed as far as plants are concerned. So questions can be asked like that. What is the biological and economical importance of seed? Biologically it is important. Economically also it is important. And I give one or two importance seed because seeds are the method of multiplication. Seeds are the means of multiplication because the plant produces seed for multiplication, because when the conditions become unfavorable, the plant has to survive. So when the conditions become unfavorable, plant began to reproduce by sexual method. So seeds are produced by sexual method usually, and seeds are showing variation because they are produced by sexual reproduction. Meiosis takes place, so seeds are showing variation. So seeds are the method of multiplication. We multiply almost all the plant by using seeds. So plant produce thousands of seed, that may be smaller or larger, produce thousands of seeds. Plants are usually multiplying in large number by the production of seeds. So plants are, as far as plants are concerned, biologically seeds are the method of multiplication. Second point, seeds are the basis of agriculture because according to the historical knowledge, agriculture has been started 10,000 years ago. Modern agriculture in the valleys of Euphrates, the banks of Euphrates and Tigris rivers, we started human civilization. Along with that, we started the modern agriculture also. And you remember that agriculture started by the production of seeds, or seeds are the basis of agriculture at that time, and now also seeds are the basis of agriculture because all the agricultural plants we are using agriculture, we are now developing that in India itself. We are trying to develop agriculture maximum. For obtaining maximum food production, we have to satisfy the requirement of growing population. So agriculture we are improving more and more. So in this present day context, it's very important. So agriculture is completely based on seed. Seeds are used for multiplication, for agriculture purpose. Seeds are the basis of agriculture in the past and in the modern condition also. Seeds are the basis of agriculture. And another importance is that seeds are used in Ayurvedic medicine. remember that Ayurvedic medicine, Indian system of medicine is completely based on plant and plant products. We have seen that many medicines are produced from the seeds of plants. Plants are used for because plants contain seed, contain various chemicals, alkaloids and oils. So like that, the Indian system of medicine called as Ayurvedic medicine, various seeds are used for producing various types of Ayurvedic medicines. Then, so like that, and seeds are various oil-like chemicals or various products are obtained from the seeds. See, an important one is oil, from the coconut oil or groundnut oil, sunflower oil, like that oil and some other products are obtained from the seeds. So biologically important and economically, we are getting economical products are obtained from the seeds. So seeds are important they are the main method of multiplication. Various are used in Ayurvedic medicine, and that is the basis of agriculture, and various products, especially oil-like products, are obtained from the seeds. So seeds are very important as far as human beings are considered. Then next see the one thing related to seed. I think already explained that there are two types of seeds. Endosperm seed and non-endosperm seed. I already explained that because some of the seed contain in most of the monocot seeds contain endosperm. Such seeds with endosperm are called endosperm seed or albuminous seed, and in most of the dicot seeds will not contain endosperm. Such seeds are called non-endosperm seed or ex-albuminous seed. So there are two types of seed, endospermous and non-endospermous. And in most of the dicots, gram or beans or like that, the seeds does not contain endosperm. Why the seeds are not containing endosperm? The answer is that the growing embryo completely absorbs the endosperm. During the growth of embryo, it absorbs the endosperm by the help of suspensor. So when the growth of embryo is completed, the embryo absorb the endosperm completely. So mature seed does not contain endosperm. That is the reason. So they are called non-endosperms. But in monocots, the embryo consumes the endosperm, but endosperm grow continuously, so that embryo cannot absorb the endosperm completely, because endosperm is also growing. So even after the maturity of embryo, endosperm, 90% of the endosperm remaining in the seed. So seeds contain endosperm at maturity because embryo cannot eat the endosperm completely. So mature seed contain endosperm. So such seeds which contain endosperm are called endosperm seed. Questions can be asked. In some of the plants, food is stored in the endosperm. In some other plant, food is stored in the cotyledon. Why? Because if endosperm is present, food is stored in the endosperm. If there is no endosperm, food is stored in the cotyledon. You have to say what is the difference between endosperm seed and non-endosperm seed. Monocots are mostly endospermous, dicots are mostly non-endospermous. So that is the difference between endosperm and non-endosperm seed. Then comes another topic called seed dormancy. Seed dormancy. It is a phenomenon by which seeds are remaining in a dormant condition, in a sleeping condition till the arrival of next favorable season. See, seeds are formed, and you remember that seeds are not germinating just after the production. You can see that in mango, seeds are formed in the February or March. But seeds will germinate only in the June or July only. Like that, in many plants, seeds will not germinate soon after the production. So seeds are produced, they will fall in the soil and they will remain till the arrival of next favorable. It is a waiting for next arrival of next favorable season. So the process by which seeds are remaining in a dormant condition or sleeping condition or inactive condition till the arrival of next favorable season is called seed dormancy. And in many plants, in many animals also, there is a condition called as estivation, hibernation, etc. These are all adaptations for overcoming the unfavorable condition. When the seed germinates in the unfavorable condition, there is no water. So if the seeds of the mango germinate in the April, soon after the production of March or April, it will not get water. So seeds will not germinate. Seeds will wait till the arrival of next favorable season. That waiting, that sleeping condition is called as seed dormancy. And during the dormancy period, usually the seeds contain 90% water. Seed contain 90, fresh seed contain 90% water. And the dormant seed contain only 10% water. Seeds are produced completely contain water. So usually when we are keeping the seed for next year, we are keeping the seed in sunlight. For drying the seed, we can call it as dehydration. Seeds are kept in sunlight for 2 or 3 days. You can see the vegetables are, we are cultivating vegetables. We are keeping the seed of vegetables for the next year. So the seeds contain 90% water. It will suddenly germinate. So if you are storing the seed for next season, we will keep the seed in the sunlight for 1 or 2 days for dehydration. So the fresh seed contain 90% water, but dormant seed contain only 10% water. This is to reduce the metabolic activities, because during the dormancy period, during the resting period or during the sleeping period, metabolic activities are minimum. So that is very important. Dormancy period is very important. In the textbook it is not completely explained. So during that period, seeds will not germinate. Seeds metabolic activities are minimum. Respiration is minimum. Cell division is minimum. Other physiological activities are minimum. And that minimum condition require less amount of water. So water is completely removed. Dehydration of the seed occur, and the seed will not germinate. It will continue the resting condition till the arrival of next favorable season. And the dormancy of the seed, various reasons are there why the seeds are remaining in a dormant condition, why seeds are not germinating. Various discussions are there, various reasons are there. You may remember some of the, in the first year we studied about some of the plant hormones you studied, like ethylene, cytokinin, abscisic acid, etc., gibberellin, etc. Some of the hormones are preventing germination. You may remember that abscisic acid is a hormone that preventing the germination, and gibberellin is a hormone that favoring the germination, breaking the dormancy. I will go to that. So anyhow, there are various reasons by which the seeds are remaining in a dormant condition. What is the condition? There will be in many plants the dormancy may extend to 1 month or 2 months or like that. In some of the plants it may remain to 1 year or like that. In a plant called various plants are there. Lupinus arcticus. There is a plant called Lupinus arcticus. It is the plant which is estimated the seed germinated after 10,000 years. The seed is obtained from Arctic region. Seed having an age of 10,000 years. Up that it is remaining in a dormant condition and germinated after 10,000 years. And you may remember that the seeds will remain in a dormant condition for a long time in some of the plants. Normally, that may extend to 1 year or 2 years like that. That may vary from plant to plant. Anyhow, seeds are remaining in an inactive condition. And when the conditions become favorable, seeds will germinate. It is a matter of controversy when the seeds are revived, which is remaining in dormant condition, and like that may vary from plant to plant. So that is about the seed dormancy. They will germinate. Then there is another topic. You may see seeds are very important in agriculture. And see, next topic is there called as apomixis and polyembryony. Polyembryony. This is the last topic in the chapter, apomixis and polyembryony. So apomixis, see, that is related to reproduction. Apomixis means formation of embryo without fertilization is called apomixis. See, formation of embryo without fertilization is called apomixis. So, usually embryo are formed, embryos are developed after fertilization only, but very rare ones, the family Asteraceae, that is important for competitive examinations. Family Asteraceae family, you study that. In the first year study, flowering plants are classified into 206 families. 3 families you study like that: Fabaceae, Solanaceae, Ligiaceae, etc. Another family is Asteraceae. In the Asteraceae, the most of the seeds are apomixed. So the formation of embryo without fertilization is called apomixis, and that is a genetical phenomenon. And how the embryos are developed without fertilization? The question is that during the megasporogenesis, you may remember megasporogenesis, formation of female gamete is called megasporogenesis, and there is a cell called, you may remember, megaspore mother cell. That megaspore mother cell is diploid. This megaspore mother cell divides by meiosis, resulting into 4 haploid megaspores. That is the normal condition. In this family, there may be various reasons for apomixis. One important reason is that during the megasporogenesis, meiosis will not take place. Failure of meiosis takes place. Means meiosis will not take place due to some genetical reasons. So, if there is no meiosis, this megaspore mother cell directly develop into egg cell or female gamete diploid egg. So remember that if meiosis has been taken place, we get the haploid female gamete. But here, due to failure of meiosis will not take place. As a result, the diploid megaspore mother cell, this is the megaspore mother cell, MMC, megaspore mother cell, this diploid megaspore mother cell directly develops into diploid female gamete. There is no meiosis. Diploid female gamete. And that diploid female gamete is already diploid. So there is no fertilization. Diploid female gamete directly develops into diploid zygote. And diploid zygote directly develop into diploid embryo. See? Diploid embryo. See, this is a very special case in some of the families only. Diploid megaspore mother cell develop into diploid female gamete, directly develop into diploid zygote, directly develop into diploid embryo. You can see one mistake there, because there is no contribution of male gamete. Male gamete will not come. Male gamete does not join with the egg cell. There is no male gamete, there is no male character, there is no male gene. Male character will not contribute. There is no male. This zygote or embryo does not contain male character. It contains female character only. And now which is utilized for agriculture in some other ways. So the process of development of embryo without fertilization is called apomixis, and this is due to various reasons are there. One of the reasons is that due to failure of meiosis during the megasporogenesis, meiosis will not take place, resulting in diploid female gamete develop directly into diploid zygote and diploid embryo. Here male gametes are not participating, not taking part in fertilization. So this diploid embryo does not contain male character, it contains female character. This apomixis is used in agriculture because this helps to preserve the good character of female parent. So the female parent, usually we are producing agriculture we are producing hybrids in agriculture, and I will give the methods of hybridization in the coming chapter. So hybrids are forming. When hybrids are forming, male and female, male gamete of one plant and female gamete of another plant is joining. So we are getting hybrid. That is the basis of agriculture. That is started in 1960s when the Green Revolution started in India. So hybrids are formed. Hybrids will contain the character of both male and female. So variations are there, but here when in the field of hybridization, agriculture, we are using the apomixis. Now we are trying to use the apomixis, and the reason for apomixis, we are trying to find out the gene. What is the reason for that? And we are trying to transfer the gene to cultivating plants. Here, apomixis is important in agriculture. That is helped to conserve, preserve the good character of female parent generation after generation. If the female parent has good character, we can use this method artificially for preserving, protecting the female character generation after generation. So apomixis is important in agriculture to preserve the good character of female parent generation after generation, because male character does not contribute. Negative sides are also there. Anyhow, they are trying to exploit the character in agriculture. So production of female embryo or embryo without fertilization is called apomixis, seen in the Asteraceae family. The method is explained. Then comes the next topic, polyembryony. A word meaning polyembryony. Polyembryony. Polyembryony is the production of numerous embryos in a seed is called polyembryony. Instead of one embryo, usually one ovule contains one female gamete, one embryo. You see that this is the structure. This is the nucellus. This is the indeguments. This is the nucellus. And there is the female gamete. Sorry, this is the, and inside there is the embryo sac. This is the nucellus. There is the embryo sac. In the embryo sac there is the one embryo. Usually there is only one embryo. But in some plants like citrus, you may remember citrus, orange, lemon, or in mango, like plants, seeds contain more than one embryo. The occurrence of more than one embryo in a seed is called a polyembryony. Usually only one embryo is present. So if more than one embryo is present, it's called polyembryo. We can take a seed of citrus and squeeze out. We can see numerous embryos inside, heart-shaped structure embryos inside. And there is one embryo is original. One embryo is actually diploid embryo containing both the characters male and female. But some of the embryos are also there. Usually the embryos are developed in the nucellus. See, that usually occurs like that. The diploid cell of the nucellus, not the megaspore mother cell. Diploid cell of the nucellus by hormone changes in the hormone. Diploid cell of the nucellus developed into embryo, female embryo without fertilization. This is the actual embryo formed by fertilization. This is the embryo, female embryo developed from cell of the diploid cell of the nucellus. And this enter into embryo sac. After some time, they enter into embryo sac from the nucellus and they mimic the normal embryo. We use the term mimic. It usually resembles the normal embryo in appearance, but this is female embryo. Does not male character, does not contribute. So there are in the embryo sac we can see numerous embryos in plants like citrus, lemon, orange, mango, etc. Of that, one is the normal embryo, others are diploid embryo, but they are more or less similar morphologically. This is the embryo with both male and female character. This is the embryo with only female character. Anyhow, the genetically maybe differences are there. Anyhow, occurrence of more than one embryo in a seed is called polyembryony. So the two terms are there. Apomixis and polyembryony. That is important for exams are also important. So why this is supposed to be the conclusion of this chapter. So something is explained in the textbook related to fruits. Fruits are usually ovary develops in the fruit. That's in the first year. And if the fruits are developing without fertilization, that method is called parthenocarpic fruits. fruits without fertilization are called parthenocarpic fruits. In banana is an example for parthenocarpic fruits. Fruits are of two types, true fruit and false fruit. Fruits are developing from ovaries called true fruit. If the fruits are not developing from any part other than the ovary, is called false fruit. Mango is a true fruit, and you may remember the false fruit, cashew nut, or apple is a false fruit. It develops from thalamus, so it is called false fruit. And true fruit and false fruit are there. Parthenocarpic fruits are there. You see in the first you have seen that parthenocarpic fruit, etc. Then like that, then there is a textbook. There is a word called perisperm. It is asked for examination. There is a part called perisperm. In the plants like pepper, you may remember the plant called pepper. In the plant called pepper, the seed contain remaining part of the nucellus. Nucellus may be as remaining axil, and if the nucellus is remaining in the seed, the remainings of the nucellus is called as perisperm. That is important in the plants like pepper. So I covered almost all the parts of fruits and seeds. Today we study the structure of dicot seed, dicot seed, structure of dicot seed, dicot embryo, monocot seed, then importance of seed, then what is the seed dormancy, then comes the apomixis, polyembryony, and the types of fruits. So I think we will complete the notebook. Notes are completed. So I will complete the chapter by this in the next class. So see the lessons tomorrow itself. So today itself. Then we can see we can complete the notes. Then see the next class. We can discuss the total chapter, and after that I will conduct a test paper for you. So complete the notes and lessons by the end of this week. So in the next week I will have a test paper for you. Then after we can discuss some of the practicals by the same method. Thank you.